Welcome to Elimu TV. This is Teacher Faith taking you chemistry Form 4. And to our viewers, you give us your name and the location where you are watching us from through this number 21450. 21450. Now, in chemistry Form 4, we are still in the first topic, but the subtopic of today will be solubility and solubility curves. Solubility and solubility curves. And the first thing we want, first of all, to understand what we mean by solubility. So the definition. The definition of solubility. Now, to define solubility, we can say that the solubility of a solute in a solvent solubility of a solute in a solvent is the maximum mass of solute required to saturate 100 grams of solvent at a particular temperature. So we are saying that the solubility of a solute in a solvent is the maximum mass of solute required to saturate 100 grams of solvent at a particular temperature. I believe we understand what we mean by a solute and also a solvent. The solute, this is the solid that you are dissolving, and the solvent, this is the liquid. It is the liquid whereby you are dissolving your solid or your solute. So we are saying that this solubility is the solute. Is the solute in a solvent, is the maximum mass of a solute required to saturate 100, we must talk of 100 grams of solvent, and also at a particular temperature. The other definition I want us to look at is what we mean by solubility curve. So the solubility curve is a graphical representation of variation of solubility with temperature. With now the temperature. Remember, we have said that during this, we are talking of 100 grams solubility in 100 grams at a particular temperature. So the curve is a graphical representation of variation of solubility with the temperature we are talking about. Now, the other part I want us to look is the uses of solubility curve. The uses. There are several uses, and this is going to help us to see the application. And the first one is, it helps us to know how the solubility of compounds changes with temperature. because we have seen that it is at a particular temperature. So the solubility of a certain compound will change depending with the temperature. If the temperature is low, maybe when you increase temperature, solubility can either increase or the solubility can decrease, depending with the compound or the salt you are dealing with. The other one, help us to find out the solubility It helps us to find out the solubility of a compound at a particular temperature. A particular temperature. So the other use is that it will help us to find out the solubility of a compound at a particular temperature, because we are saying solubility depends with the particular temperature that is being given. So we will look at several examples that will help us to see how we are going to apply these uses. The third one, it helps us to find out the mass to help us to find out the mass of a salt which would be obtained by cooling a saturated solution a certain known temperature. So the third one, we are saying that it will help us to find out the mass of a salt which would be obtained by cooling a saturated solution from a certain known temperatures. Now, we will be able to see this because we will have the mass of a certain compound when it is at different temperatures. Maybe at 40, the solubility is at this, another one at 60, the solubility at this. And therefore, from that, we can be able to work out the mass of a salt which would be obtained by cooling, maybe from 60 degrees up to 40 degrees. We will see the change in mass. And the fourth one, it will help us to separate two compounds. Help us to separate two compounds with different solubility, maybe compound X and Y with different solubility from a mixture by crystallization process. Process which is known as fractional crystallization. So we are saying that the fourth one, it will help us to separate two compounds with different solubility. Maybe you can have a compound X and Y which are having different solubility from a mixture by crystallization process known as fractional crystallization. Sometimes you can be given a question and be asked, how can you separate these two compounds X and Y? Therefore, if they are having different solubility, then that method of separating it, we are calling it fractional crystallization. So from this point, I want us to look at some examples that are going to help us to see the uses as we have discussed. The four uses we have discussed, we can be able to see them from this question. The first question, I want us to look at what is the solubility of potassium nitrate in water at room temperature. Room temperature. And you have been given some information from the experiment. Results below. One of the experiment that was done, the temperatures of solution is 15. 15 degrees. We have the mass of the dish plus the watch glass to be 55 grams. And the other one we have the mass of the dish plus the watch glass plus the solution. And that one is giving us 85 grams. 85 grams. The other one is the mass of the dish plus the watch glass plus the solid salt. And it is giving us 61 grams. So you have been given that what is the solubility of potassium nitrate in water at room temperature from the experiment below. So once you have that question, we want first of all to look at the working. We can be able to get the mass of the solution. And how do we get the mass of the solution? We have already been given the mass of the dish plus the watch glass alone is 55. And then we have been given the mass of the dish plus the watch glass plus the solution. So if you want to get for the solution alone, then you take this one minus the 55 is equals to the mass of the dish plus the watch glass plus solution minus that one for the dish plus the watch glass, which would be 85 minus 55, which is equals to 30 grams. The next one is to get the mass of the solute. Mass of the solute, we have been given this one, so it will be 61 minus this one for the watch glass and the dish alone, so it will be 61 minus 55, which we are able to get that 36 grams. The other one is to get the mass of the solvent. Now, to get the mass of the solvent, we already have for the solution and we already have for the solute. Because remember we said that solution is equals to solvent plus the solute. And now because you already have for the solution and you have for this, so you can be able to get this one, and therefore it will be 30 minus 6 is equals to 30 minus 6, which is going to give us 24 grams. So this is not the answer because the one we have gotten is just for the solvent. But remember what we have said, that you need to talk of 100 grams. So we know that 6 grams of the solute, you can say that 6 grams of the solute will dissolve in 24 grams of the solvent. But we talked of what about in 1,000. Remember our definition? Remember our definition for solubility, that we are talking of in 100 grams of the solvent. Therefore, if we are saying that 6 grams is in 24 grams of water, what about how many grams are in 100 grams of water? So this one becomes our subject, and from here then we can say that 6 times 100 over 24 is equals to our x, by 6,1 by 6,4 by 4,1 by 4, 25. So we will know that our x is equals to 25 grams. So I just repeat here. From this point, what you're supposed to do, you get the mass of the solution, you get the mass of the solvent, and you also get the mass of the solute. And you have obtained the mass of the solute to be 6, the mass of the solvent to be 24. The mass of the solution was 36, and from solution we can be able to get now the solvent. Then it tells us that the 6 grams of the solute is dissolving in 24 grams of the water or of the solvent. Therefore, our solubility, we said that you are talking of 100 grams of that solute at a particular temperature. Therefore, the ones we are getting 6 grams are only dissolving in 24. So you need to ask yourself, what about when you are having 100 grams of water? Therefore, it tells us that to get 100 grams of water, then what we need to do is that we cross multiply and we'll be able to get the 25 grams. That will be our solubility. And the temperature we are talking about, remember, when we are defining solubility, we say that it is at a particular temperature. And the temperature now we are talking about will be at 15 degrees C. So that becomes our solubility. So we have only been able to deal with one example. And maybe just to make a summary, my main interest is that we need to understand what is solubility, the definition of solubility. A question even can be define the term solubility. And therefore, we are saying that solubility of a solute in a solvent, it is the maximum mass of solute required to saturate 100 grams of a solvent at a particular temperature. Maybe the word I did not explain is saturated, meaning that it cannot dissolve anymore. More solute cannot be dissolved. So we are saying when it has become saturated, it cannot dissolve anymore at 100 grams of the solvent at a particular temperature. Therefore, the example we dealt with, we were only first of all able to see that 6 grams is only dissolving in 24 grams of the solvent. But our question was solubility. Therefore, solubility, we need to ask ourselves, what about 100 grams of the same solvent? So we called it X, and after cross-multiplying, we were able to get our X is 24 grams. At a particular temperature, or temperature, therefore at 25, not 25, it was 15. So at 15, it is able to dissolve potassium nitrate. We can say that potassium nitrate will dissolve 25 grams at 15 degrees C. So that becomes the solubility of that. The other thing I want us to understand is that process. We have said that process whereby we are able to separate two compounds, X and Y, we have called that process fractional crystallization. The process to separate that with different solubility, salt with different solubility, we have called it fractional crystallization. So I will stop at that point, and I say that when you are defining the solubility, then you need to give the key points. So back to my viewers, to be able to get more tips in chemistry, you said Chem 4 to 21126. Chem 4 to 21126, and you'll be able to get more tips in chemistry.